So, very good morning to you all, and welcome to the third session of the module Geoprocessing using Python. So, today we will discuss about a very fundamental library of numerical computing, that is Numpy, and later on we will discuss how do we visualize different images or create graphs using matplotlib. So, just a quick review of what we learned yesterday. So yesterday we talked about the basics of Python programming. So how do we define a variable in Python, and then how do we assign a value to a variable. Then we discussed about creating list defining few functions, and reading and writing files. So build on these basic constructs. Today we'll go ahead with the next session. Here we will introduce you Numpy and matplotlib. Actually, yesterday when I was seeing, a lot of questions were asked like, can we use Google Colab for this as well? So yes, definitely you can use Google Colab. Actually, if you don't want to install anything on your system, then you can directly go to the Google Colab. There most of these libraries, Numpy, matplotlib, and all these are already pre-installed. So you just need a Google account, and there itself you can create your Jupyter notebook and start writing the code. So you are free to use either. If you don't like this VS Code, then you can go to Google Colab, or there are actually many other IDs also available like PyCharm, or even some people were asking if we can use directly Jupyter Notebook and Anaconda. Yeah, definitely you can use Jupyter Notebook with Anaconda as well. So you need to just start the Anaconda navigator there in your environment. You need to just install the Jupyter Notebook, or either you can install the Jupyter Notebook through command line as well. So depending on your convenience and choice, you can choose any way to use. So either if you are comfortable with VS Code in Jupyter Notebook, you can use on VS Code itself. Otherwise, you can go Anaconda or Google Colab. So today we'll discuss about Numpy and matplotlib. So the Numpy part, actually this total tutorial here is completely based on this Numpy Illustrated, the visual guide to Numpy by Lev Maximo. So this is the link for this tutorial. You can go through online as well. So the entire tutorial is based on this link, and the matplotlib portion has been is based on the tutorial available at matplotlib.org. So you can refer to these links as well. So let's start with Numpy. So Numpy, or numerical Python, is an open source Python library that is used in almost every field of science and engineering. So whatever problem, if you are going to solve any problem in any field of science or engineering, so Numpy is the base library. So there are a lot of libraries, almost actually all the computing or libraries which are used in science and engineering are built on the top of Numpy. So even if you are going for the deep learning frameworks, those things are also like TensorFlow and PyTorch. So these are also almost built on the top of Numpy only. So now if you are going to solve any problem of engineering or science using Python, so you must learn Numpy. So it is the universal standard for working with numerical data in Python, and as it is the core of scientific Python and PyData ecosystem. So even if you take geospatial data and any other thing, so Numpy is the core library for all these things. So if you master Numpy, then you can easily adopt to anything else. So Numpy API is used extensively in Pandas, SciPy, Matplotlib, scikit-learn, scikit-image, PyTorch, TensorFlow, so many things. So Numpy library contains multi-dimensional array and matrix data structures. So when we talk about images, so images are two-dimensional data only, 2 or 3-dimensional data only. So Numpy library contains is a library for handling these multi-dimensional array and matrix data structures. It provides ND array. So the basic class of Numpy is an ND array, a homogeneous n-dimensional array object which with methods to efficiently operate on it. So the data is represented as n-dimensional array, and NumPy provides various methods to efficiently operate on that multidimensional array. So plus NumPy can be used to perform a wide variety of mathematical operations on an array. So it can be it is basically to suppose if you want to apply any mathematical operation on an array, so NumPy is the library to be used for that. So like these are the examples like how the arrays are used. So we will talk about these in more detail. So first thing, before using NumPy, let us see how do we install NumPy. So for installing NumPy, if you are using Anaconda Navigator, so directly you can go to the Anaconda Navigator and there activate your environment and activate your environment and select the packages which are not installed, or you can open Conda prompt, activate your environment and just there type Conda install NumPy. So with Conda install NumPy, you can install NumPy to your active environment. So once a NumPy is installed, so as we explained that by default Python interpreter doesn't load all the modules. So it basically loads only the modules which are necessary or what is in the core Python which are required. So first thing, we need to import NumPy. So import NumPy. So either you can write like import NumPy. So when I write import NumPy as NP, what does it mean? It means that hereafter NumPy will be referred as NP. So instead of I need not type hereafter full NumPy, so I can just refer NumPy just as NP. So it will save me typing. So hereafter, so if I import a package as with using like import NumPy as NP, so hereafter NumPy package I can refer as NP. So suppose if I have to create an array or a list, just like we discussed about list, a list of 6 elements with starting from 0 to 5. So for that I need to call a function called np.arange. Arange is quite similar to the range function what we discussed yesterday. So arange is an equivalent of range. So np.arange 6, it creates an array of one-dimensional array of 6 elements. So if I do this, so you can see that this A is created with 6 elements starting from 0 to 5. So 6 is excluded. So 0 to 5, 6 elements. So you may ask a question like this things looks quite similar to the list what we discussed yesterday. So what are the differences between a Python list and NumPy array? So NumPy gives us an enormous range of fast and efficient ways of creating arrays and manipulating numerical data inside them. So basically NumPy is basically for handling numerical data, actually the list, while a Python list can contain different data types within a single list. But all elements of the NumPy array should be homogeneous. So what you can say that NumPy is specifically has been built for fast and efficient handling of numerical data, while Python lists are quite general in nature. So Python list can contain any type of data. So the basic convention like Python list can be can contain homogeneous element, like a Python list can contain a tuple inside it, or an integer or a string or floating point number. But NumPy arrays, all elements of the NumPy array are homogeneous, so they all will be numeric types only, because NumPy specifically has been designed to handle numerical data. So NumPy arrays are faster and more compact than Python lists, because NumPy arrays are specifically designed for handling numerical data. So these are faster and more compact than Python, because Python lists are quite general in nature, so they can handle any type of data. So because of specificity, NumPy arrays are faster and more compact. An array consumes less memory and is more convenient to use for numerical data. Plus, actually NumPy arrays are like, once you defined a NumPy array, then you cannot change the size of an NumPy array, but at least can expand over time. So NumPy arrays are slower than lists when you append elements to an end. So what you can say that NumPy array once created, thereafter increasing the size of NumPy array is not permitted. Or even if you are somehow, if you increase the size, but that will be very, very slower compared to the Python list. So NumPy array, so whatever array size if you need to define the size while you are creating an array. So contents of array you can change over time, but the size of array is fixed. So suppose if you want to increase the size of NumPy array, that is a bit difficult and it will be slow. So it is not recommended to increase or change the size of an NumPy array after its creation. So with these differences, let's discuss about an array. So what is an array? Array is the central data structure of NumPy library. So an array is just a grid of values, like we discussed about yesterday. A list contains multiple elements. So similar way, array is a grid of values. Then similar to the list yesterday, array also can be indexed by a tuple of integers. So NumPy array can be indexed, so like indexing, so every element will have an index. So once you created an array, suppose if you want to fetch back the values at different indexes, so then those indexes can be a tuple of integers, or you can create Boolean indexes, or you can create another array of indexes to fetch the array. So the rank of array is the number of dimensions. So an array can be, if the array is at a single dimension, like if you need a single index to access any element of array, that is called one-dimensional array, two-dimensional array, or three-dimensional array. So in NumPy terminology, rank of the array is number of dimensions the array has. Then the second thing we will be referring, the shape of array. So what is the shape of array? Shape of array is a tuple or tuple of integers giving the size of array along each dimension. So an array can be one-dimensional, two-dimensional, or three-dimensional. So when an array is two-dimensional, its shape will be like number of elements in its rows and number of elements in its columns. So that defines its shape. So let us see how do we create an different types of array, now 1D, 2D, or 3D. So vectors are the vectors. So in NumPy parlance, so vectors are vector 1D arrays, or vectors are called one-dimensional arrays. So let us see how do we create a one-dimensional array. One-dimensional array means it has a single dimension, like it may be just, it is just a list of elements. So a single element. So vector, like in vector, row vector or column vector. So vector initialization, one way to create NumPy array is to convert a Python list to NumPy array. So the basic thing is like you first create a list and then call np.array. Like here, suppose if you want to create a vector or one-dimensional array with one-dimensional array that has a single dimension. So here we are calling a equal to, so a is our variable in which we are storing the array, np.array. So for creating a basic array, the class is np.array. So then inside this array you can pass a list of elements. Like if I want to create 1 point, comma, 2 point, comma, 3 point. So this way you can create a one-dimensional array. So this is the same thing. So when I run this piece of code, a equal to np.array, to this array I am passing a list of arguments, list of elements. So I am passing it a list of 3 elements with the value 1, 2, and 3. So when that array is created, so the type, these every element will have a type. So these are basic, by default these are numerical types. So these numerical types can be integer, floating point numbers, or complex numbers. So by default, depending on what we have typed, the type will be auto deduced from its element type. So like if I write here 1 instead of 1 point, if I write 1, 2, 3, the elements will be of type integer by default. Otherwise, like if I am trying 1 point, 3.0, 2.0, or 1.0, these will be of type floating point numbers. So if I create like array as np.array 1, 2, 3, so then data type of each element will be np.float, 64-bit or double precision float. Then if you see the shape actually this particular array has a just one dimension. So there are just 3 elements on this. So if you type the shape of this, it gives 3 comma. So because there are only 3 elements and there is only one dimension, so it gives just a single number. As we explained that shape of an array is number of elements in each of its dimension. So if I type here like A, so you can see then array. So like if I type A dot D types, A dot D type gives the data types of an elements of an array. So it is D type float 64 bit float, or you can say double precision float. So as we explained, NumPy arrays cannot grow the way Python list does. So no space is reserved at the end of array to facilitate quick appends. So but as we explained in the case of Python lists are expandable. So NumPy arrays cannot grow. So it is a common practice. So suppose if you want to increase or append something to the list of an array, so it is a common practice either to grow a Python list and then convert it to a NumPy array when it is ready to pre-allocate the necessary space with np.zeros or np.empty. So what is this like? So you can, suppose if you want to create like no space is reserved at the end of the array to facilitate quick append. So common practice, so you can create a Python list. So in that Python list only you add all of your elements, like with if it is supposed to increase. So later on with that list you can that list itself you can convert to the NumPy array. So like here, suppose if you want to create a list with just 3 zeros, or suppose if you want to create a list with 3 zeros, so you can call a function like there we are calling np.arange. So here you can like call np.zeros. Then in this you can specify like how many elements you want into your list. So np.zeros 3 and type like data type of a particular element what you want to do. So then you can pass like int, float or whatever, like np.zeros zeros, then you can like 3 comma, then d type you can specify n, or you can say int or float 64. Now if I see B, so I have created an one dimensional array with elements of each array initialized to 0 0 and type of integer. So similar thing. So sometimes it may be a requirement that you want to create an array which matches the existing one by shape and elements type. Suppose you have created an image. So now similar image, suppose you want to just copy that image after some processing or something, you want to apply some operations, or sometimes your requirement is that you just want to create an empty array which matches the existing one. So there is you have created an existing array, and now similar you want to create an element of an array of the same shape and size and type of also same types. So then you can call the functions like So suppose you want to create an array of all zeros that is similar in shape and type of another array called A. So here we are creating a new array called C, whose shape and elements are of type A. So here like if you see A, I create an A. So here we have created A to be of like I call it A. Here I have created an array A of size 3 with integer as its data types. So here I am creating np.zeros like A. So a new array C will be created whose shape and element types will be as same as A. So here array will be created like 0 0 zeros and float 64. Here actually I have called it float is this, I will call float 64. Float. So this way we can create an array by copying or like the array of the same shape and element type what an array we have defined previously. So all the functions that create an array are filled with a constant value have a underscore like counterpart. So like there are multiple functions as we discussed about np dot zeros. Np dot zeros create an array whose all elements are having the value 0. Similarly, there are multi other functions like np dot ones which creates an array which has all elements 1, or np dot empty. So np dot empty creates an empty array, like the values will be very near to 0, e raised to the power some 0. So what you call garbage values or empty values. So similarly, there is a function called np dot full. So np dot full fills all the arrays, like this. First we are defining the shape, and second is the value. So we are creating an array with 3 elements, value of each element to be 7. So once, like suppose if you want to create an array filling with certain value, maybe 7, 8, 9 or 10, then you can call the function np dot full. Like np dot ones create an array with value once. Now suppose if you want to create an array with values of 7 or 8, then you can call this function np dot full. So these all functions which are creating an arrays with some specified values have an counterpart with name underscore like. So like np dot zeros underscore like a. So it creates an array whose shape will be same as the shape of a, but values will be filled with zeros. So like np dot ones like, np dot empty like, or np dot full like. So this will create an array of same shape and size as of a. So full like will create an array of, and pre-existing will create an array which is array of shape and element type based on a previously defined array. So now suppose if you want to initialize array with a monotonic sequence, like we are creating an array of 0, 1, 2, 3, 4, 5, 6, 7 and so on. So there are as many as 2 functions for this. One way we can initialize NumPy arrays from Python list using a nested list or a higher dimensional data, with 2 or higher dimensional data. Or like suppose if you want to create an array, so similar to our so either like you can create an list of one dimensional, 2 dimensional or 3 dimensional, and we can call just np dot array on that. Like you manually create the list or using for loop or something else, or then convert it to the NumPy array. Or there are different functions available, or there is another function called arrange. So that is, this arrange is equivalent to for a range function in Python. So like suppose if you want to create an array with values 0 to 5. So there are different options available for this. So this is a function called np.arange. So np.arange functions takes 3 arguments like start, stop and number of steps to increase at each step. So first function, like if I call np.arange and if I pass it a single argument, so that will be stop. So the array will start from 0 and end just before 6. So 6 is excluded. So 0 to 5. Now if I pass it 2 arguments, so 2 arguments will be taken as start and stop. So if I pass np.arange 2 to 6, it will go from 2 to 5. Then if I pass it 3 arguments 1 to 6, and third step is step. So it will go from 1 to 6 and in steps of 2, like 1, 3 and 5. So like the same thing, if I run it, it creates an array np.arange 616, 2. But what happens, this arange is not good at handling when you have floating point numbers. Right now, suppose if you want to generate numbers from 0.4 to 0.8 with the steps of 0.1. So basic thing what you can do, generally you will write like 0.4 to 0.7, suppose if you want to generate. So you can just write 0.4 np.arange 0.4 to starting 0.4, stop at 0.8 and steps of 0.1. So this generates numbers like this. But there are certain issues here, like suppose if you type it like, because of the floating point comparisons, Like suppose if I write like 0.5, if you write the function like 0.5 to 0.8 with an increment of 0.1. So what it does, it includes 0.1 also here. So the solution is either you can use like 0.5 to 0.75 and in steps of 0.1, then it generates number into 0.5 to 0.7 range only. So handling floating point numbers with a range function is a bit tricky. So there are other functions for this. So this is called, there is a function called line space or linear space. So here you can pass three arguments like start, stop, and how many elements you want to generate, right? So the step will be calculated automatically by the function itself. So suppose if I write like 0.5 to 0.7 and I want to generate three numbers, so then it will calculate the number of step size required for this. So like here the step size required is 0.1, so automatically step size will be calculated to be 0.1. So suppose if you want to generate a monotonic sequence of floating point numbers, so then instead of a range you must use this line space function. Like here if I show you np dot line space, so 0.5, 1.0 and 10. If I .5, 1.0, 10. So you can see that it generates 10. So similar things, I suppose if I want to, instead of 10, I want to generate 100 elements in this range. So the step gets automatically changed. So whenever you want to handle floating point numbers, you must use np dot line space. So suppose for generating random numbers, also there are multiple functions available in NumPy. So like suppose if you want to generate random integers in range in this closed interval, open interval 0 to 10, so then you can call np dot random dot randint. So random dot randint, then here you need to specify low range, high range. So this high range is excluded because this is an open interval. So then three, like how many elements you want to generate. So suppose you want to generate three random numbers in range 0 to 10, then you can just call np dot random dot randint 0 to 10 and 3. So you will see the output like 4, 3, 7, or so it generates the number in uniform with equal probability in x belongs to 0 to 10, an open interval, and three numbers we are generating. So actually there is a difference between, like in core Python also this random dot randint is there. So in randint it generates, it is a closed interval, and in this case it is an open interval. So similar way, suppose if you want to generate the numbers or floating point numbers in range 0 to 1 in with mean 0 and standard deviation of 1, then you can call random dot rand and specify the size, like 3 elements you want to generate, 4 elements you want to generate. So if you want to generate random integers, you can call randint, otherwise you can call rand. So rand will generate the numbers in range 0 to 1 with mean 0 and standard deviation of 1. Similarly, other functions are available, like you can call random dot uniform or random dot normal distribution. Then you can specify like a normal distribution with, suppose if you want to be numbers to be generated with specified mean and standard deviation. Like here we have defined np dot random dot normal distribution, numbers to be taken as a normal distribution with mean value of 5 and sigma of 2, and 3 elements will be generated with the specified mean and sigma. So np dot random dot normal. So this way you can generate different random numbers. So apart from this, there is also a new interface for random array generation. It may be better suited for multi-threaded environment, and it is somewhat faster and more configurable. So that is like default range. So for that, first you need to create, like, instead of calling directly random dot rand or randint, you can first create an like random number generator. So for that there is like np.random.default rng, default underscore default random generator number. So once you created this range object, so in that you can call these functions to similar way. Now it is rng dot integers. Then whether endpoint you want to include or not, you can pass another argument to this. Then range dot random. These are equivalent to their like rand int or rand. And similar way, like suppose if you want to with standard normal distribution. So in case of standard normal distribution, with standard normal distribution, numbers will be with mean 0 and sigma 1. Now suppose if you want to generate numbers from a normal distribution, but given with your given mean and sigma values. So same thing like range dot normal. So same thing, whatever was there, random dot normal, then you create a new random number generator, and in that you call these functions. Now next thing comes indexing. Now once we have created an NumPy array, so NumPy gives you gives multiple brilliant ways of providing easy ways to giving it back. So now once we created an array, now our requirement be like we want to access these elements. So NumPy gives a lot of flexibility in accessing those elements using indexes. So there are multiple type of indexes, like suppose we take an example here. We have created an array A, np.arange 1 to 6. So we have created an array of 6 elements here. So the index of elements starts with 0, 1, 2, 3, 4, 5. So first index of the first element is 0, second is 1, 2, 3, 4. So this way it is incrementing. And there are negative indexes also, so that we will discuss later. So like the if you say this will be the -1, though if you want to refer to negative indexes, the -1 will be the index of the last element. So -2 will be the second last, -3 third last, fourth last, fifth last. So positive indexes start from left to right, and negative indexes start from right to left. So 0, 1, 2, 3, 4, -1, -2, -3, -4, -5. So this way, now once we have created an array, every element of the array has an index. Now suppose if you want to access first element from this array, so we can call it like name of our array and in square brackets index number. So A1 will give us the second element, because first element's index is 0 and second element's index is 1. So A1 gives us the number 2. Then you can slice as well, like we discussed yesterday in case of strings. So if you pass like A2 colon 4, 2 colon 4 means 2 is the starting index and 4 is the ending index. 4 will be excluded, so it will return the third and fourth element from the array. So this is like 2 means A2 3 and 4. So third and fourth element will be returned back. Now another way is, so slicing. In the case of slicing, actually here we saw that we have passed 2 arguments with separated by a colon. Now suppose if you passed only single element, so A -2 colon. So what it does, if like first is start index and second is stop index. So if any one of them is missing, suppose end index is missing. So if end index is missing, it means that go up to the last. Or suppose if the starting index is missing, it means go from the start, go from the 0. So A -2 colon means go from the -2 index to the last index. So A -2 will be like, this will be -1, 5 is -1, then 4 is -2. So -2 to end. So it will print 4 and 5. Then another thing is like you can pass an step number also. By default, what happens? It goes step by step. So now suppose if you want to print only alternate elements from the entire array, so you can pass it on like this: colon, colon and 2. So colon means here starting and ending are missing. So scan the entire array, and 2 means step size is 2. So include only alternate ones. So like 1, 3 and 5. So if I do it like this, Then even then, like suppose if you have to access multiple elements together, so to an array indexes elements you can pass an second array itself. So here like to A we are passing, so we want one first, third and fourth elements also together. So you can pass index and other array as well. And similar way we can assign values to also. Here we are just accessing the value. Now suppose if you want to assign 2 to fourth element, second and third element you want to assign zeros, you can write it like this also. A2:4 equal to 0, then it assigns these values gets changed to 0. So like this, if I show you code, like here I create an array. So suppose if I want to access multiple elements of this array together. So like if I want to access 0th element, I will just write A0. Then if I want like A0 to 3, it gives 0 first, 2 and 3 as second element. Now suppose if I have like I want non-contiguous element from the array, like I want second element, then first, then 0th. So this way I can pass in elements to be accessed as an array as well. So it gives this array as well. So this way you can index any element of an array. So apart from integer indexes, you can have Boolean indexes also. Like suppose if we created an array A like these with these values 1, 2, 3, 4, 5, 6, 7, 5, 6, 4, 5, 3, 2, 1. Now if I write like A greater than 5, so what if I write A greater than 5, it creates an Boolean array. So with the same shape as our previous array, but whenever a element of A is greater than 5, it will assign that new array, the value will be false, and wherever A is greater than 5, it will create an array with values true. So like if I have an array like this, if I write A equal to 5, A greater than 5, it creates a new array which will have the same shape as our previous array, but elements of this array will be like it will be false wherever this A is less than 5, and wherever A is greater than 5 it will be true. You can see here array like this will be created. Up to 5 values are false, these are false, and wherever A is greater than 5 the values are true. Then like you can call these functions, like suppose if you want to check in your array whether any value of the array is greater than 5. Like suppose you have created an array like, or you have an image and you want to check whether the value of any pixel is greater than certain threshold. So then you can call the function like np.any A greater than 5. So it checks all elements of the array. If the elements of any of the element is greater than 5, it returns true. Then similarly, now suppose from this array, if you want to access only the elements which are greater than 5, so you want to filter this array, then you can write this A greater than 5. So it returns only the elements which are greater than 5. Similarly, now suppose if you want to check whether all elements of your array are greater than 5, like we want to check whether all elements are greater than 0, then you can call np.all A greater than 5. So here all elements are not greater than 5, so then it returns false. So similar to this, like accessing the element, now suppose if you want to write, like you want to change, like wherever A is greater than 5, you want to assign them to 0. Like suppose the in your image pixels above certain threshold, you want to clip them to 0. So like then the same code you can write with a single statement like A greater than 5 equal to 0. So it will assign wherever elements which are greater than 5, it will assign them to the value 0. So like here this was our original array. Now these values were greater than 5. So now with this statement we change these values to 0. Similar way you can combine multiple conditions together as well, like wherever A is greater than 3 and A is less than 5. Suppose those values only you want to make it 0. Then there are multiple operators like you can make OR, XOR or NOT. So this way you can combine multiple conditions as well. A is greater than 0, A less than 5 and so on. So similar to a writable Boolean indexing. So these what we call writable. Here we are not just accessing the elements, we are just overwriting those elements as well. So like suppose there is another function like if you want to get the indexes of the elements where a is greater than 5. There we were just directly accessing the elements. Now suppose if you are interested only knowing the indexes, their locations, so then you can call that, like there is a function called np.where. np.where a greater than 5 gives us the indexes where a is greater than 5. So here you can see that a is greater than 5 at these indexes 5, 6 and 7th indexes. The value in these indexes 5, 6 and 7 indexes are greater than 5, so it returns 5, 6 and 7. Similar to this, there is another function called np.non-zero. So np.non-zero a greater than 5. Here you can write your condition. So this gives the indexes. This np.where or np.non-zero are not giving the elements where a is greater than 5. It is giving the indexes of those elements where a is greater than 5. So writing Boolean indexes can be like, you can write this way also, like a less than, suppose if you want to write something like initially you have an array like this and you want to change wherever a is less than 5, you want to make those values to be 0, and wherever a is greater than 5, those values you want to make it 1. So what in the conventional way what you can do, you need to write in 2 steps. So first you will write a less than 5 equal to 0, and next line you will write where a greater than 5 equal to 1. So these 2 steps you can write this way, or the equivalent for these 2 steps is you can directly use np.where. So like you can write np.where a is greater than equal to 5. First thing to the np.where will be your condition, and if the condition is true, what should be the new value? If condition is false, what should be the value? Like you can write like these 2 statements can be replaced with a single statement np.where a is greater than equal to 5. So wherever a is greater than or equal to 5, those values will be replaced with 1. Otherwise, other values will be replaced with zeros. So np.where you can write. So similar thing, like suppose if you want to clip the values, like if the values are less than 2, you want to make it 2, and if the values are greater than 5, you want to make them 5. So then you can write these way only, a greater than 2, a less than 2 equal to 2, and a greater than 5 equal to 5. Those values. So that an equivalent function for these 2 statements is np.clip. Then you write a to, this is lower clipping value and upper clipping value. So values which is less than 2 will be assigned the value 2, and above 5 will be clipped to the 5. So this way, these are very basic functions we have. Actually, there are a lot more functions available in the Numpy library. So you can just go through the documentation and learn about those functions and use as per your requirements. So this is just a tip of the iceberg. So there are a lot more functions available in this. So then let us see that how do we apply vector operations, like we have created an vector or one-dimensional array in Numpy. Now how do we apply certain operations to that one-dimensional vector or 1D array or 1D or vector? So arithmetic is one of the places where Numpy speed shines most. So Numpy is extremely fast for handling vector operations. So ultimately, actually, vector operators are shifted to the C++ level and allow us to avoid the cost of slow Python loops. So ultimately, these operations are implemented in C++. So we need not write Python loops like in our programming language. If we are writing for I into this to this. Then, but in case of Numpy array, just we need to write a single statement. Then all the loops are eliminated. So Numpy allows the manipulation of whole array just like an ordinary number. So we will see with example. So we need not write loops. So like we are adding a number to a scalar. Similar way we can add numbers to, or we can apply the operators, different mathematical operations to the entire vector as well with a single line of code. So like here, suppose if we have created 2 arrays with these values, like one array was with value this and another array with another array with 2 elements 4 and 8. So suppose if you are writing this in Java, C or C++, so we will write for I equal to 0 to this length, then AI equal to AI plus BI, CI equal to BI. So but in Python, we will just write this first array plus the second array. So we need not write the loop. So just it will apply these operation element wise. So 1 plus 2, 4, 8, you get the answers like this. Like same thing like plus, minus, multiply, divide, then integer division, or you can apply the exponential operation as well, like 3, 4, exponentiation 2. So 3 exponential 2, 3 raised to the power 2, 9, 4 raised to the power 3, 64. This way, all the mathematical operation can be done with a single line of code. We need not write loops. So the same way integers are promoted to floats. Suppose when there are, so in this operation, if you see that the resulting operation is a float. So these, or when we can try like adding integers and floating point number. So what will happen? The integers will automatically gets promoted to the floats. So similar way. So when we try to add, subtract, or do some operations on an array and scalar, on a scalar number, what happens? These scalars get promoted or broadcasted to an array also. So let's see with an example. Suppose if you want to add a linear algebra. Suppose we have an array of or a vector of 2 elements. Now suppose if you want to do some addition operation on this. So what should happen, that this second array also should be of the same size as of the first array. Like suppose if you want to add 3 to each element of this array. So the second array also should have the same size. But in case of Python, what it does, suppose if you want to add some scale, multiply, add or subtract some scalar from your one-dimensional array, then what happens? This 3 gets broadcasted by default to the shape of this array. Actually, there are certain limitations to that you need to go through the documentation. How there are certain rules for broadcasting. It is not that every time it works. So like here, 1, 2 plus 3. But whatever is happening, this 3 gets added to each of the elements. So this is what is called broadcasting. So this scalar number is getting broadcasted. So suppose if you want to subtract 3 from each element of this one-dimensional array, so you can just write this array minus scalar number. So same way, multiply, addition, or this. So this is what you call broadcasting. Otherwise, in linear algebra, I cannot do like if the shape of there are strict rules for the shape and size of an array. But in case of NumPy is quite brilliant enough to understand this, and it automatically broadcasts, like it understands that I want to add number 3 or this scalar to each element of an array, then it internally broadcasts this to make 2 elements like 3, 3, then adds 3 to each of this element. So similar way, there are other operations, like suppose if you want to do square of each element of an array, then you can write like a multiplied or double star 2, or suppose if you want to calculate the square root, exponentiation, or whatever you want to do like log. So these are directly functions are available, np.log and your array. Suppose if you want to calculate the dot product of 2 vectors, then you can call np.dot. It calculates the dot product. Similar way, if you want to calculate the cross product of 2 vectors, then you can call np.cross. It calculates the cross product of 2 arrays. Now similar way, you can calculate sine, cosine, arc, sine. So there are different functions available. Then you can just call np dot. So you need not run a loop. So just np dot and function. Similar way, you can call max. Max gives you the max of your array. Minimum gives you minimum of the array. Sum, mean. You can. Then another thing is like max, and there is function argmax. You want to know, if you want to know the index of the maximum number. So it gives the index of the maximum number, like a dot argmax equal to 2. It is giving 2. But the index of 3 is 2, 0, 1, 2. So it is returning 2. Then argmin, you can calculate mean, max, whatever you want to calculate, you can calculate. This was all about one-dimensional array. So similar to this one-dimensional array, you can create an matrix. So matrix is a 2-dimensional array which will have where the numbers will be arranged in rows and columns. So a 2-dimensional array also can be created in the similar way what we were creating a 1-dimensional array. But here you can see that now I am creating with a nested list. So np.array. So then here I am creating like opening two brackets. So 1, 2, 3 first row, 4, 5, 6 second row. First row, second row, then close. So if I run the code like this, and matrix gets created with 2 rows and 3 columns. So like 1, 2, 3, 3 columns, these 3 columns and 2 rows. So the data type anyway by default, these are because we have not written 1, 2, 3, so this is of type integer. Now if I run the command like a dot shape, so as I explained, the shape gives number of elements. Shape of an array is a tuple describing the number of elements in each axis or each dimension. So now it has 2 dimensions, so its shape gives 2, 3. 2 means first number of rows, 2 rows and 3 columns. So similar to one-dimensional arrays, there are functions for two-dimensional array also. Like suppose if you want to create a matrix of 3 cross 2 with all zeros, so you can just call np dot zeros 3 cross 2, np dot ones 3 cross 2. Similar way, np dot full of 3 cross 2 with the values 7 filled to this. And suppose if you want to create an I matrix, then you can call or all type. Well, the diagonal elements are 1. np dot I 3, 3. Then if you want to create an empty matrix, np dot empty, and define the shape. Right. So similar way you can generate the matrix of random numbers. So there we were passing a single element to the shape, like we were passing just 3 only. So here we are passing a tuple of number of rows and columns, like np dot random dot randint 0 to 10, and by a shape of 3 rows and 2 columns. So similar way you can create any random numbers and so on. Similar to one-dimensional array, so two-dimensional array can also be indexed in the similar way. But as you know that for accessing a one-dimensional array, we needed a single index, because there were this was just a list of elements. So whether 0th element, first element or second element. But in case of matrix or two-dimensional array, for accessing any element, we now need 2 indexes. One is the row number and second is the column number. Now suppose if we have created an array like this, A with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now suppose if you want to access the element in first row, actually you can say this second row and third column. So suppose if I want to access this 7, so I need to write like A 1, 2. So second row and third column. So now here we are passing 2 indexes. Similar to now, suppose if you want to access the entire row. So what you can write, suppose you want to access this second row entirely, you can write A1, so here instead of column, if you just write colon means all columns. So first row, all columns. So similar way now, suppose if you want to access an entire column, so you can pass it like A all rows and column number, so it will give access the entire column. So similar way, like suppose if you want to for all rows for column 1 to 3, and this way you can create different type of indexes. So similar to the slicing, you can do like you can pass on different numbers and create different types of indexes. So the second argument in case of two-dimensional array is axis argument. In many operations, we need to tell to NumPy if you want to operate across rows or column. Okay, suppose if you want to apply certain operations row wise or column wise, so then to these operations we can pass another argument called axis. So NumPy introduces a notion of axis. The value of axis argument is the number of index in question. So on which index or on which dimension you want to apply that operation, depending on that we need to pass the index. So the first index is axis 0, second index will be like axis 1. Suppose if you take a two-dimensional array, so all the rows will be index 0 and column will be the index 1. So like suppose if we have an array like this, and suppose if you call dot sum function on this array, so what it will do, it will add these all elements together and return us the sum. Now suppose if you want to add all these elements this way, all row wise, so then we can pass like this array dot sum, and if you pass it an argument like axis is equal to 0, then it will add these all elements row wise and give us the result. Similarly, suppose if you want to add them column wise, then you can pass some axis equal to 1, then elements will be added axis wise. So this way you can apply, like depending on your requirement. Suppose if you want to apply that in particular axis, then you need to pass the axis argument accordingly. Similar to one dimensional or 1D array, same operations we can apply to the two dimensional array as well. Like suppose if you want to add two matrices element wise, then you can create an array, first matrix plus you can apply second array. You need not write any loops. So these, like if this A was an array with shape 2 by 2, B also is with shape 2 by 2, I need to just write A plus B, then it gives me the array by adding all element by a new array by adding all elements one by one. So same way you can apply minus operation, plus, or cross, whatever. So similar to as a generalization of broadcasting from scalar, so these as broadcasting applies to two-dimensional array as well. So now suppose if I want to divide each element of this NumPy array using by a number 9. So I will just write this divided by a scalar 9. So internally this 9 will be broadcasted to a two-dimensional array of the same shape as of this array. So NumPy will do it automatically. Like suppose this you are doing to this. Suppose now this in this every row you want to add or multiply, every row you want to multiply by this element. So this can be done automatically. So but there are certain rules regarding this broadcasting. This is not like you do anything, but there are certain rules that you need to follow for broadcasting. You can just go through the documentation and read about how the broadcasting takes place. Similar to the one dimensional, now 2D, in 2D also you can apply different statistics like min, max, axis wise also you can get min, max, and so on. Next is three-dimensional and above. So because as we explained in starting itself, so NumPy is for handling multi-dimensional arrays. When we create three-dimensional arrays by reshaping a one-dimensional vector or converting a nested Python list, the meaning of indices is z, y, x. So the like when we are creating a three-dimensional array, the indexes are like first is the number of planes. Like if we see a three-dimensional array, so three-dimensional array also can be created like this. Suppose I have created an array like this. So this is a three-dimensional array. So if I print the shape of this array, first index of this three-dimensional array is the z dimension or number of these planes. Then second is y. Then third goes the x. Z, y, and x. So if the three-dimensional array can be created like this only, np.array. Then here we need to create first plane, second plane, and third plane. Now if you see the shape of this array, it gives us first gives the indexes of the planes, then in the y dimension, then in the x dimension. Like if you see this, this is a three-dimensional array. Now if we give, now there are three planes in this array. So 3, 2, 4. Now there are three planes in array. So these are the three planes. And second is y, two number of rows in every plane and 4 columns in every plane. So this gives the dimension of this array. So like similar to one dimensional array, you can create generic three-dimensional arrays by calling like np.zeros and specifying their shapes and so on. So like these may be our images in RGB. Okay, this was about array. So now for accessing any element of the three-dimensional array, we need three indexes, like first plane number on which plane we want to access, then row and column. Now next we will talk about matplotlib. Matplotlib is a Python plotting library which produces publication quality figures, and it provides very easy interface. So whenever, suppose if you want to plot some image or something, so matplotlib is the library for visualizing this data. In this lecture we will cover my matplotlib.pyplot module specifically for handling or visualizing the images, this which we'll be using in the next lecture. So in pyplot first thing what first we need to call plt dot plot. So we'll first, this is the so in anatomy of a figure or plot in matplotlib is like the entire thing or the entire canvas is called a figure. So in this figure there may be multiple axes. So like in a single figure you can create multiple axes, so that every figure inside the figure, every plot is called an axis, and in every axis there will be like x-axis and y-axis. So we will come to this later. So this is general anatomy of a plot. So the entire canvas is called a figure. So now a figure can have multiple plots. Like in a single figure we can draw multiple plots. So every plot inside a figure is called a axis, AXES. Please don't confuse this axis with the axis. So in every axis there will be like x-axis and y-axis in which the data will be drawn. Then these are other things like major tick levels, minor tick levels, and so on. Now let us see some basics of how do we plot using Python. So basically there are essentially two ways to use matplotlib. Actually first thing is explicitly create figures and axes and call methods on them. So as I explained that first you need to create a figure. On that figure you can create axes and explicitly call them plot method on those axes. Or otherwise second way is you just let the matplotlib's pyplot package itself to automatically create and manage figure and axes and use pyplot functions on them. So we will see both of these approaches. So the advantage of using explicit creating figures and axes is like, suppose once you created a figure and axis, so later on in your code also you can refer to that code explicitly. But in case when you are leaving it to the pyplot, so in that case referring to the, like suppose if you want to do some modification to the axis later in the code. So in the case of when you are using when you are using the second approach, that will be a bit difficult. So you can, depending on your convenience, you can use either of the approach. So anyway, I will be going through both of these approaches. So first thing we will first explicitly create figures and axes and call methods on them. And the second approach, let pyplot automatically create figures and manage those axes and so on by itself. So first thing you need to install matplotlib to your environment. So the same thing like conda install matplotlib. So once a matplotlib is installed, so we will be using the pyplot module of the matplotlib. So I need to import matplotlib.pyplot. So then I am referring it as plt. So actually what happens, the implicitly matplotlib works on numpy arrays only. So if your data is in list or some other format, so explicitly you need, suppose if you want to plot that data using matplotlib, then explicitly you need to convert it into numpy arrays. So here I am creating first an x-axis I am creating a range 0 to 10.2, and in y I am just converting the sinusoidal of this function. So like if I see x is this and y will be sine of this. Now the first thing is we are explicitly creating a figure and axis. So for that you need to call, in plt there is a function called plt.subplots. So plt.subplots creates a figure, an axis, and a figure and an axis inside this figure. Then on that axis we need to call specifically the plot function. So actually does this plot ax.plot, actually it takes multiple arguments. So here we are passing it like just two arguments, x also is a numpy array, one dimensional numpy array, and y also a one dimensional numpy array, x and y, and what label you want to attach to this plot. So if you see this plot, here a plot got created with in the x in these values, and y is the because x we created from 0 to 10, so it has gone from 0 to 10, and y is the sinusoidal of these x's, right? And this, like this, we have written in 2 steps. Now suppose if you want pi plot itself to automatically create the figure and axis for you and manage it, then you can, there is another shorthand, like you can directly call on PLT itself, PLT dot plot. Not, instead of creating this figure and axis, directly on this PLT itself you can call the plot function as well, PLT dot plot, and the same argument it also takes. So once your plot is created, you for freeing the resources, you can close it. Similar way, now suppose if you want to create multiple plots in a single axis. So like here we have created an x, then we are creating a y sine, y cos by using this. Now suppose if I keep on calling PLT dot plot, so it keeps on adding new plots to the same axis. So here now we have plotted 2 series on the same plot. Like I called here first PLT dot plot x, then y sine, then I have given it a label sign, then an argument like line width, then I have created another plot on this. So actually there are 3 plots here, because of which we are seeing this line as thick only. I will remove this. So this will like PLT dot plot, then you can keep on adding new series is to this particular axis. Actually here we have created a figure with a single axis. So later on, suppose if you want to create multiple plots. So there the subplot command specifies, so there is an, like here we have created a subplots command, then there is another command called subplot. So subplot command specifies number of rows, columns, plot numbers, where the plot number ranges from 1 to 1, and you can create an arbitrary number of subplots. So suppose inside a figure you want to create multiple subplots. For that there is a function called PLT.subplot. So till now we had created using PLT.subplots, but now this function is subplot. So you need to take care whether you are calling subplot or subplots. So same thing, I am creating an x. Then I am creating 2 y variables, y sine of y and cosine of y. Now suppose if I want to create multiple axes or multiple subplots inside a figure. So then there is, suppose now I am following the second approach where pi plot itself is handling. I am not specifically creating these subplots. In the first approach I am letting the pi plot itself manage the subplot. So first thing I need to call a subplot function. So PLT dot subplot, so it takes 3 arguments. First is like how many rows and columns you want to create inside this plot. Like I want to create 2 rows and 1 column, and here I am referring to the first subplot in this plot. So in that first subplot you plot PLT dot plot x and sine of y, and the title to be sine plot. And same thing I am calling again PLT dot subplot 2 by 1. And now second time I am referring the second subplot of this plot. Then again in the second I am plotting x and cosine of y. If I do like this, so here you can see that this is the first axis or first subplot, and this is the second axis or second subplot. Here we have arranged them in 2 rows and 1 columns. So similar way, now suppose if you want to arrange them in 1 row and 2 column, you can pass 1, 2 and plot. This was for 1-dimensional arrays. So now suppose if you want to plot a image. So basically an image is a matrix or 2-dimensional array. So let us see how do we. So the detail of plotting or visualizing the image data we will see in the subsequent lectures. So this is just for basic, like how do we use matplotlib for visualizing those images. So today we will in this lecture I will just be showing you reading some PNG image. So coming lectures we will see how do we read and write GOT for different raster formats altogether. So So here we will be reading image just using the matplotlib itself. So matplotlib also has an function for reading an image. So and but it can read a few formats only, like PNG and other PNG format only. So first thing, I am importing the matplotlib.image module, which will be used for reading the image. So matplotlib.image, that I will be referred as mpimg, and pyplot anyway it is already imported. Even if I don't import it, doesn't make a difference. Then I am importing here an OS module. So actually this with os.chdir, what happens actually when I call this read function, it searches for the file in current working directory only. So either I need to specify the full path of the file, or another approach is like I just change my working directory to the directory where the file is available. So with os.chdir, I am changing my working directory to the directory where some PNG image is available. Okay, here now I have changed my working directory. Now suppose if I want to read some Tehri, I have an image called tehri.png image. Now if I suppose I want to read that image, so I need to call this mpimg.imread function. So this imread function reads this Tehri PNG. So now if you see this image, this is a RGB image. So if I see, this will be a three-dimensional array. If I see the shape of this array, the shape of this array is like this: 3057 into 352 by 3. So this is a 3-channel image. So as I explained, so the first are number of rows, then second is number of columns, and actually this is not actually number of rows and columns. This is in the shape like so Y, X and Z. So if I see this shape 0, so it says RGB. So this is like rows, columns and channels format. Now suppose if I want to see this image, so then directly I can call plt.imshow. So there we were calling the function like plt.plot, but in case suppose if you want to plot an image or two-dimensional array, then you need to call the imshow function, plt.imshow, and you pass on the image and you see the image. So here this way you can plot a RGB image. So as we saw that this particular image is a three-dimensional RGB image. Now from this image, suppose if you want to extract only some particular band, suppose if I want to extract, because this is an RGB image, I want to extract only red band or green band or blue band. So then I can get suppose a red data. So I assume that RGB is red data is in the first band. So then I use these array indexes, all rows and all columns and 0th channel. So this gives the red data. So the same thing now, suppose if I want to visualize the only red band, so then I can call plt.imshow on this red data. So we have extracted only the red band. So similarly now this is shown using some default color map. Now suppose if you want to change the color map of this image, then you can pass on to this imshow function a second argument called cmap. Then suppose if you want to see it in grayscale, then you can call cmap.gray. Now suppose if you want to, here we don't know that what value this different shades of this is represented. Now suppose if you want to attach a color scale to also to this image, then you can just call plt.colorbar. So with plt.colorbar you can attach a color bar also to this image. So this way we can, suppose if you have to visualize an image, you need to call plt.imshow. For visualizing one-dimensional array, plt.plot, and for visualizing two-dimensional or three-dimensional array, you need to specify plt.imshow function. So then similarly, like you can enhance the contrast, like you can clip the limits and so on. So there are multiple functions available to this, and all figures you can plot together and so on. So thank you very much for today's lecture. If you have any questions, you can please post the questions, and after 5 minutes I will answer those questions. So thank you very much.